Hello everyone, let's talk about this question. In this question we're given a string s and we have to split it in a way that we are maximizing the unique elements in each of those splitted parts. Let me explain what that means. Let's start with a fairly easy example. We're given this example here, which is just the string a. We can see that the number distinct characters, let's say, in this case is equal to 1 because there's only the character a which is in here. However, the question requires us or wants us to separate the string in a way that it's separated into two strings. So they essentially want us to make this string into something like a, which is the first string, and the other a, which will be the second string. So this first string and this is second string. And for each of these strings or substrings that we have created, they want us to figure out the number of distinct elements again. Number distinct in this case would be 1, and number distinct in this case will also be equal to 1, but they want us to add these numbers, the one here and the one here that we got from the separated or split strings, and find the maximum value that we can find here. There was only one way to split this string, so our solution here will essentially just be 1 plus 1 equals 2, which is what we expect here as well. We're given a and we expect the output to be 2. We can do the same with these examples as well. In fact, let's do it to see how that would work. In example 2, we're given ABC, ABCD. Directly we can see here that distinct here is equal to 4 because there's A, B, C and D. However, if we split the strings into ABC and ABCD, which will be this part of the string, that's first string, and this is the second part of the string, we can see that distinct equals 3 in this case, and distinct values in this case equals 4, and our sum here becomes 3 plus 4 equals 7. That is the question that we have to solve. There is a relatively intuitive way to solve this. However, that implementation is of n squared, which is not great, but I'll still show it to you and explain how that works. The idea here is, let's take this example again, and our idea here is to essentially work our way through the string and calculate the number of distinct elements on the left side of the string and the right side of the string. So for example, we were, let's say, split it like that, and we are at that point. We will look at the left substring that we have found. We'll find that we have three unique elements there, and then we'll look at the right side of the substring that we had found, and we'll see that we have 4 distinct elements. We will continue doing this for other numbers as well. So let's say we will split it like that, and we'll find that our left substring here has 3 distinct elements, and our right substring here also has 3 distinct elements. Now the sum in this case was 7, and the sum in this case would be 6, which is not ideal. So this is our solution, but we would have to go through each of these values or part of the strings and calculate the left side and the right side values. That would be an O of n square solution because we'll use n time for running through the string and n time for calculating right and left, which is not good because these will be nested inside each other. Our final time complexity equals O of n squared, which is not our ideal solution. I did solve this version first, and then I realized that that wasn't the best solution. But if you still want to look at the code, the one that's commented out is the code for n squared solution. Now let's talk about the optimal solution. We can see here that we're spending time running through the string, which is something that we have to do. There's no other way to go around that. And there is another nested function where we're calculating the distinct elements for the right and left strings. This portion is something that we can change and we can optimize for that. Rather than doing this, we can make sure that there's no doubly nested things that we're doing. Let me explain how we can do this. The idea here is to create what I call prefix and suffix values. Let's just use the same example that we've been using now. ABC, A, B, C, D. When we're calculating prefix values, we will simply iterate through the string and calculate how many distinct elements are at each point. We'll keep track of the total new or distinct values as well. Let me show you what that means. When we figure out the prefix values, we will be iterating through the strings and essentially tallying how many distinct elements we have found until that point. So for example, when we start off with the first element, we will see that there's one unique element. When we go to the second element, which is B, we'll see that there's two elements in this substring. When we go to C, we'll see 3 new values, but when we go back to A, we'll know that we still only have 3 distinct values. We go to B, we still get 3 distinct values. We go to C, we still have 3 distinct values, and when we go to D, we will have 4 distinct values. This is the prefix value that we have calculated. We will do the same thing for suffix, but rather than going from left to right in the string, we'll go from right to left. Let's work with our suffix values. We'll start off with D, and we'll see that there's one distinct value. The C over here will show us that we have 2 distinct values. The B is another distinct value, and the A is another distinct value, so we have 4 here. Now we go to C here, and we still have 4 distinct values. B and A here will also have 4 and 4 distinct values. Once we have done that, we've done this outside of our main loop. So this will be O of n operation. But once we have done that, and now we can go to our main loop, where we will be calculating the sum of prefix and suffix values and simply storing what the maximum value we were able to find was. So when we go through this, let's do it right here as well. Max values. When we're calculating max value, we'll be looking at the first part of the prefix values and the second or the next value in the prefix value that we have stored. We do this because we don't want any overlap. So we can see our max value for the first one will be 1 plus 2, which is 3. Then we'll go to the second prefix value, 2 plus 3, which is 5. Now we go to the third prefix value and the fourth suffix value, so 3 plus 4 is 7, and we keep on going like that. Once we have found all of that, we would have stored the maximum value that we had, and we will just see out the max value. That is the crux of this question, because this operation will also be O of n, but since these are not nested, the overall time complexity will be O of n. This is the most optimal solution I know of, but now let's get into the code. I will start off with my template. We will input test cases, and while test cases minus minus or is positive, we will input n, which is the number that we're inputting, and the string that we have to perform operations on CNS. Since we need to store unique values, one of the most powerful ways to do this is just using a hash set, which can be done using an unordered set in C++. So unordered set of characters, let's call it unique characters, and we will also have a vector of the numbers or the strings of the prefix and suffix. We can do it like this: vector integer prefix. We will make sure that the prefix is the size of n and all values are initialized to 0. We will do the same for suffix as well, and now we have to populate these suffix and prefix vectors. We'll run a for loop for this, for int I equals 0, I less than n I plus plus. We will update unique characters by inserting this value to check if that is a unique character. If it is a unique character, it will be added to the unique characters set that we had created, and our prefix in this case will become the size of the unique character, which we can see here. After this, we will clear out our unique characters because now we have to use it for our suffix vector, and we will do the same thing, and I equals n, because we're n minus 1, because we're starting from the back of the string. I is greater than equal to 0, and I minus minus. If that is the case, we will update unique characters, and suffix at I position will become the size of unique characters. Once we have done that, we have populated the suffix and prefix. We will now go on to our main loop. We'll initialize our answer, which is 0, and then we will go to each of the spots in the string like we did in the previous O of n square solution as well, like that, and simply compare. Our answer at each position will be the maximum of answer, and prefix at I plus the suffix at I plus 1. Once we have done all of that, all we have to do is see out answer. And the reason for prefix I and suffix I plus 1 is that we don't want overlap, and this is the best way that I know to do that. All we have left to do is to include unordered sets and vectors, and that is the code. This is the one that I implemented with. If you can find out a better, more optimized way to solve this, I would love to know that as well. That is it for this video. Thank you so much for watching.